going to be talking about cross-site scripting in 2023, the mitigated and mitigated vulnerability. The reason for this title is that despite the various mechanisms available in 2023, it still remains one of the most common vulnerabilities in web apps. So the aim of this talk is to provide upcoming testers with the approach to finding more of these vulnerabilities. And then I will conclude with a recommendation of in-depth implementation. So first, let's just quickly define what's cross-site scripting, and it's just the injection of malicious input that leads to client-side JavaScript execution. There are a few types, but this is the key point to understand. So let's jump straight into the first topic, and that's documentation. So whenever you find like unique parameters, mentions of certain libraries, do investigate them. Developers use often a combination of custom code with existing code, and the interaction between the two can lead to a few vulnerabilities, not just XSS. So an example, I'm going to give a scenario, is this URL, and essentially all it did, this is not the exact URL, but it's inspired by the real one. All it did is send a request to a backend engine. Then it had various components, and one of those is menu, so it asks do the click action, and it provides a result. Then the backend would try to get all the different components that are required to show the final page. At this stage, the reflected input was both URL encoded and HTML entity encoded, so no vulnerability yet. After doing a little bit of research, I found documentation of one of these parameters, and you could actually change it to resource. So when you change it to resource, at first it gave me an error. Why? Because once it's a resource, it doesn't need an action name, so we removed that. And once it's removed, something interesting happened. The first request got to the backend, it goes to the menu component, and it simply loads it in its raw form without the other components. At this point, there was no HTML encoding or URL encoding, so you could escape from the string in the view mode, escape from that string, and insert whatever payload you want. And that's the importance of documentation. And next, let's jump straight into, chaining vulnerabilities. So wherever you can, it's not always possible, but when you do chain them together, especially if this can show an impact to the client. An example I'm going to give is a limited union by SQL injection. SQL is just a structured query language for relational database management systems. And by limited, I mean imagine all the data is publicly available, so no sensitive information. And access rights, the interesting functionality is disabled. So you don't have a lot of impact yet. And think of the URL being something simple like this, translating to this query roughly. So after you can enumerate how many columns there are, and once you find one of the equivalent of a string type, you can actually use your union payload and inject a string within one of those equivalent of a string type, usually also called varchars. And if you can, and there's some type of trust that all that data is only entered by an administrator in a restricted network, if that SQL injection exists and there's that trust, they might not HTML encode it, and you'll have a XSS now. And if there are admins on this application, you can now chain your SQL injection, which was previously very limited, to target admins on the application. And continuing on this journey, do remember stored HTML injections. So a lot of times your HTML injections, when they are stored, they will not lead to XSS, mostly to content security policy. But you should still be able to demonstrate impact to your clients. Using meta tags, you can force redirection, right? So an example is a victim visits a vulnerable application that has that HTML injected redirect, and now they get redirected to a malicious server, which can have a login page that's a clone. That's a clone of the other application login page. And you can say something, your session has expired, re-enter it again. And by doing this, you can demonstrate to a client that now it's a compromise of integrity. So the application is no longer being used as it was initially intended, and now is serving as a redirect proxy for malicious servers, and clients won't be happy with that. And going back to the previous point of chaining vulnerabilities. So if you have cross-site request forgery, this is another thing you can really chain together, especially if it's HTTP based. So if it is some parameter that's HTTP that creates any change, this ignores same site likes cookies, and essentially you don't have to worry about same origin policy either. And by chaining these two together, you can also make the actual user perform an unintended action. And with that, let's talk a little bit about customer journeys. So when you are looking into stored XSS, look at all the combination of different actions a user could take, like A, B, C, or A, C, B. An example here is simply, you have a page, and let's say as you fill it out, your form, it's getting HTML entity encoded as you fill it out. No issues here. You publish it. And as you do, it's also HTML entity encoded. And this is when you always take a step back. What other actions this user could do? And so what about saving that form? If you save the form, what I seen in this assessment per se was there was XSS. This is still not good enough because for a client, well, it means another user would have to view your malicious saved form and save it again. So going another step, what about deleting that form? And once I did, it also showed, okay, there's XSS there. Now is more impactful to a client because if there are administrative users, they look and they see why some other users save this suspicious looking form. Let's delete it. And that's how you have your attack path that's realistic. And now error messages. And I think error messages should be your best friend, not just for XSS, but any type of vulnerability. The more error messages you get and the more unique they are, the more things you will uncover. So here's an example of a long URL. There are a few nuances here, and it is inspired by a real one with everything changed. But the key point here is not looking at something like, oh, I see HTTPS, let's think about server-side request forgery. Instead is how many error messages you can get. What if you change the protocol? Does the DOM pop up a unique message to you? And DOM is just a document object model. That's the structure of your pages, web pages. And so things like this, try to think creatively, like put some random characters, don't even worry about XSS yet. Try to changing that part that said object to something different, not object equaling whatever. And keep being as thorough as you can, looking at how many error messages you can do, even adding extensions that weren't there. So to recap, do research and read any available documentation on anything you find, even if it's a web app test that's focusing on a client-side vulnerability. Chain vulnerabilities wherever you can as well to demonstrate more impact. Leverage those store injections, such as to facilitate phishing attacks. Follow all the customer journeys. So do look at ABC, ACB, and do remember, it's not just you clicked all the actions, it's also you've tried to see what happens when those actions are used in different orders. So it's not just you did, I publish, I delete. What if you just try to delete someone's and then you try republish that deleted by using some IDs that were left over? So then the last one is identify all unique error messages and its triggers. And the key point here is unique error messages and the triggers. So the more you can get unique error messages using some trigger that you can manipulate, the more XSS you'll find. And with that out of the way, let's look into implementing the defense in depth approach. So essentially, the core issue for the majority of cross-site scripting vulnerabilities is the lack of HTML entity encoding. So the solution is HTML entity encode all input. By all input, that means user input and input that's coming from sources that you might perceive as legitimate, including your database systems or other web sites owned by the same organization. So anything that shouldn't be rendered or interpreted as HTML should be HTML entity encoded. If you already have pre-existing libraries and things that do not support it for whatever reason, which they should at this point, you can just add a wrapper around the function that you're using and make sure that input is encoded before being passed to the next function. And after this, you can start thinking about filtering and escaping potentially malicious characters such as this \. This is more for some nuanced DOM-based XSS things and to avoid some JavaScript encoding such as Unicode, or even attempts at escaping from certain string contexts. Then you can start to implement your HTTP-only flag for relevant cookies. This is session cookies, right? So by doing this, it will prevent injected JavaScript or JavaScript in general from being able to access the browser's cookies via the document object. And then re-authentication for high-risk actions. So a high-risk action could be deleting a user, changing an existing user's password, or shutting down a server. By re-authentication, you simply prompt a user to re-enter their password when such high-risk action is performed. And equally, when the injected JavaScript tries to replicate such action via a request, it would require to know that user's password. I've seen in the past where some XSS I found, the biggest impact I shown to a client is because I didn't have re-authentication and I was able to perform really bad actions as an admin. And after this, I think everyone's favorite is content security policy. So it is more at the top because first it has to be effectively set, and by effectively set so means that it's restrictive. So by being restrictive in nature, in a good implementation, is not always something that all clients prefer to do. At least not in the correct implementation. But what this does is just a set of directives or rules that tell a compatible browser what type of content it should load. And then on top of this, you can deploy also your web application firewall, simply to demotivate less motivated adversaries, essentially. And the reason I've put web applications and firewalls and this content security policy more at the top of your in-depth approach strategy is simply that's a mitigation that is quite effective, at least content security policy when correctly implemented, but is not by itself a solution to the underlying problem. And yeah, I think at the start I went a bit too fast. I'm sorry about that. So for that reason, I'll have questions for everyone now. So no problem.
Yeah, any questions?
Hi, how do you think generative AI will assist or hinder your cross-site vulnerability scanning and methodologies?
Assist, I don't think per se cross-site scripting is a difficult vulnerability to uncover. So the things that AI currently can assist in cross-site scripting is something you can already do via fuzzers. So it will use already very commonly exploits and try them. And luckily, if it does have some, I forgot the name, but it's when it can go backwards, relearn and forward with a piece of data that is received in one iteration. If it can do that, then yeah, it could probably help. But in general, at the moment, what I've seen from my experiences, most of XSS that I found in general was because it hasn't been found previously by the tools available that scan them. If AI can do this in the future, then I think it's great. I think we should all, in general, accept new technology and push towards implementing and coexisting with new trends.
Anyone else? Cool. Well, once again, big round. Oh, no, sorry, there's one more. Here we go.
Like, for an AppSec program, if you want, like, for a product security engineer who is directly working with the application, and if you want to have a detection mechanism for XSS in a continuous CI/CD workflows, what would be the best approach you would suggest for identifying this injection vulnerability? Not only XSS, but XSS is one of the topic, but yes, other.
You mean identifying this during the software development cycle?
Yes,
like
yes.
throughout it? So I think the first step is always having a good, basically not education, but having resources that can teach your developers to understand this vulnerability. So that's always the first step. And making sure that they are aware of how these vulnerabilities occur. And then in your development process, it should be by the start, you have a policy where you HTML encode all input that shouldn't be HTML, as I said in that in the first core issue. Once you do that, if you adapt this and if you use wrapper functions, for example, around your already existing calls that put the input through, if you implement that, then you should be fine in general. I don't know if that answered your question, so if you can reiterate, it's fine as well.
I mean, definitely that prevention, the methods which you mentioned, that's absolutely correct. Education is actually vital, most vital. But the other thing which you mentioned about, I think you're referring to the input validation, right? Yeah. So I think in your defense in depth approach, was there mention in that? Because I did see there was a filter one, but I think there wasn't a whitelist like what we typically recommend to the developers that follow a whitelist approach using regular expressions for input fields.
Yeah, so that's a fair point. So you could use allow lists when focusing on potentially malicious characters here for filtering and escape. So you could use a list of only characters you want, right?
Exactly.
That's perfectly fine. But that HTML encoding all the input, what it does is, in the sense that you want people to be able to use certain characters, but you don't want them to be executed, right?
Correct.
Then HTML entity encoded would be preferred because you would still want those people to be able to use those greater or minor signs. For whatever reason, you want to give them that ability. That's fine, as long as that HTML encoded when it gets reflected on any of the pages.
So you mean to say, like, if we give a bit liberal in not implementing a input validation regular expression for, like, say, first name field, then it would be fine to a certain extent. Is that?
So I get the question. So the key point here is your strategy in general, right?
Yeah.
So if you focus on this strategy, you will first fix the instances and any potential of XSS of occurring at all before even allow listing. So it's similar to having, for example, a SQL injection.
Parameterized queries for SQL injection.
Yeah. So if you prevent SQL injections, your filters are just a second step. Because they're already getting properly prevented, such as with parameterized or using ORMs that are securely developed. If you have that, it will already prevent. So your filters is only a top ahead of this. And those filters are there to also give you an additional protection in case that you failed to fully implement the first step. Because if you fully implement the first step throughout your whole application, and as you, in your software development cycle, when you create new updates and add new functionality, if that same methodology is followed to HTML encode all type of input, you're already preventing the actual vulnerability in itself. If that makes sense.
Yeah, that is definitely, that's the primary mitigation. HTML encoding is the primary mitigation. Coming back to the same question about HTML encoding, like nowadays a lot of frameworks also provide so what do you like the standard API for HTML.encode or for framework specific inbuilt? There are a lot of inbuilt features as well, which actually allow the developers to natively use the encoding features, encoding capabilities. So can you give some example of such framework or something? Or what do you suggest to the developers that?
So I think in general, almost any framework like Spring Boot, for example, if you use.
Or is it to be relied on because we never know how they have implemented?
So if they are open source, you are able to check the implementation and you'll be able to, and you'll be able to check in the implementation. If it's open source, you'll be able to see that piece of code that actually does the encoding, and you'll see if it's secure, or you'll have a team that's able to analyze if it's secure at that instance in time. So another thing important to consider is that even open source, any applications they grow with time, right? So they develop with time. There are new updates, and sometimes new updates include vulnerabilities. So today, the actual library you are using might be secure HTML encoding, and a new update might show up that changes a bit of that code, and it might be now vulnerable in the next update. Which is also a reason why some vulnerabilities are not discovered in 1998, because some of them were introduced in 27, but that's just to explain that point.
Yeah,
Sorry,
obviously a lot of
debate.
discussion to be had about this topic, and it's quite in depth. But once again, thank you very much to our speaker today.